Hello everyone, welcome back to my channel again. So today is episode 3, collecting data from the different sources. Sorry, I need to write data from the different sources actually. In your MLOps project, anytime that anything that you wanted to be satisfy your business problem, you need data. So data is the first thing that the organizations are needed actually. Just a minute. Yeah. So like where you get the data, you have multiple data sources, right? You take it as an example of e-commerce, take it as an example of any your infrastructure data, you take it as an example of anything, that then from where you get the data. Let's understand, you have an application here. Okay, you have an application here, this is an application, and this application, every organization, they will be connecting their own DB, right? Their own DB. It could be a SQL, NoSQL, MySQL, Postgres, and Mongo. So like this. Okay. So here you're keeping the customer data and what transactions he has done and what the things uh, done, right? So all this data you would be keeping in the database. So that is the primary your customer data of your application uses. And then this data is enough for your ML model to develop to solve your business problem. No, not actually. You need multiple data actually. So this is the data that you know. Example, a user is there, a user is there. So this user is logging into this application. This user is logging into this application. And this user will be signing up or login into this application, right? Will sign up with some basic information, email, Gmail, and all. But how can you find a pattern of the user when he is not even though logged into your application? How can you collect a lot of data, these kind of users on the internet, Google? So you have a different data sources. Example, I'm telling. You have API, you can get it from the API, okay? You have DB, your company DB, and you have warehouses, your warehouses, okay? And you'll be having the Google Analytics. Google Analytics, from the Google Analytics, you will be bringing the data. This is API, this is DB, and this is warehouse, and like other social media, okay? Like your Facebook or Instagram, somewhere you wanted to be collector. However, mostly your Google will be solving that issue. So this is the data that you need to collect. You need to get it. Example, this is a user who is ordering something in the Amazon. You need to get the weather data. How you will be getting the weather data? You need to analyze the weather where the user is sitting over there. Will be able to deliver the product to him or not? Okay, let's understand a problem. As this is Diwali right now, you are logging into the Amazon and you're selecting one product, and then that product is actually giving you the estimated time. So we would be going to deliver in this given time period, like tomorrow, today, tomorrow 7 a.m. to 9 p.m. in a time window. But how that is actually calculating that accurately? So similar way, if you ask your friend who is in Bangalore or in the Chennai or in the other country, it would be changing, right? So how? Sometimes in your location there would be rain, it would be sunny, or some it may happen some environmental hazards as well, right? Like some troubles might be happen like floods or heavy rains and all. So in that cases, how they going to calculate? How they are actually getting it? How the ML model is working behind the scene? So they need to have the data. They will be also getting this the data in the real time. and they would be analyzing. There are two things. One is batch data and one is real-time data, live data. Batch and real. So let's understand in the from the basic level of view so that it will be very clear to us. In order to train my ML model to predict in a certain date I'm going to deliver this product, what things I need a data to get this prediction. Okay, so from Google Analytics, I can have the click rate, means user behavior, click rate, and other things. And from the social media, I can collect some other data. I already have my application data uh, in the warehouses, like in the DB also, and I will be connecting weather data. All this data you will be collecting. You'll be collecting. See, some organizations, there's a ETL and ELT team would be responsible for it. Running all these tools, means pipelines, data pipelines, and then keeping into things like ETL and ELT. ETL and ELT. ETL is comes first and ELT is comes later. So ELT, what they would be doing, they will collect all this data from the different sources and putting into one place before getting into the target system. And then ELT will load the data, extract, load, and transform. Then there will be a kind of filtering would be happen and making it as a fine-tuned data, and that data you can use. So this data you can use. So here, while you are using this data, there is a step called EDA, exploratory data analysis. So in this exploratory data analysis, what happens? A team will try to find out, uncover pattern, missing data. You will explore the things, what are the features you took in it actually, and outliners, nothing but missing data. You are finalizing the outliners in the data and all, and then feature engineering will be coming into the picture. FE, feature engineering. This feature engineering, you're transforming. Okay, you're transforming given uh, features to predict the target value. Let's say in your EDA you are already finding out the pattern, so you will understand in a more visualized way. You can able to find out the anomalies and you can trying to doing that EDA to fix it up the outliners and understand the data structure. Then the feature engineering, what happens here? You will be transforming the features. Let's say I have some amount of X features. Then can I derive the new feature by using the existing features? What I'm trying to say is, for this user to train my model, I need thing. Okay, let me take a table here. So this is the data. You have different data. Okay, you have text data, you have tabular column data, you have numeric data, like this. So here is a user ID, the amount he has done transaction, and the location. Okay, and means pin code, location, and it would be his email ID, and here it is like at what payment method he has used, UPI, credit card, something like that. So this is the data, means by using this click rate data also, I can understand the user behavior and all. I would be collecting all this data, and I'm keeping in this a final table. Okay. Here I have the values. Here I have the values like this. So these are the features actually. Based on this, you can predict, right? In how many days you can able to deliver the product, right? Even you are with your human brain, you can see that okay, this particular product, this particular category product, is it present in my inventory or not at its location by looking at the weather conditions. Simple. You can easily predict, your brain can easily predict that 1 or 2 days I can deliver you. Similar kind of prediction need to be happen at the application side. So you have this data. Based on this one, you have to derive this one more feature. Okay. And here you would be doing some adjustments. Let's say there is duplicate lines, some missing values. Okay, missing values. In the location part, somebody is actually entered wrong pin code, which is not identified. But it will save. But on such cases, how you can manage this? You need to fill with average values. Sometimes all the data coming from the users is not correct. You have to fill the average values, right? So this is something called feature engineering will be done in this part and in this part, and then you will use a feature store. Means all the features are finalized. It is so here you will be using a feast online and offline. You can store it, means I was telling that batch and batch and real time. Real time. Two things. Batch and real time. Batch means you're getting the data from this, you're getting the data from this on a like weekly once, a bunch of data, monthly once, a bunch of data by using Airflow. Okay, you're doing by using Airflow and DAX and all, you'll be creating the pipeline and where it can bring the data and put it into some target place. So that is you can use. And the real time is something that when this user is actually doing or playing something here, so there's a click rate. Okay, so click log, click rate from the Google Analytics or somewhere, you have to get this data. So how you will get this data? We can use Kafka. Okay, Kafka, PubSub, all this DynamoDB and Kinesis. Okay, AWS Kinesis. So this data will be to the live stream. Okay, so by this data you'll be doing the inference. Okay, means so this is go to API and then your ML model will be predicted, and then again you can store back into your feature into Redis or DynamoDB or any cache kind of thing. You can maintain it. So it's again, this process would be changing from one company to another company. Okay, based on the infrastructure they have designed and the existing system of the data connectivity and the application connectivity, and they're bringing up the data, transforming into this ML ops side, would be based on the architect and the persons who are designing these connections in your company. Okay, so this is how this data will be collected, batch and real time. You can use this tools for the bash and the real time. So you can also go through my notes. I will be going to give you in the um, description. If you see, every ML model need a data flowing from the different sources, feature models and production. Batch is nothing but you collect the data periodically, daily, weekly. So real time is nothing but streaming. So there would be a collecting, processing, streaming. Okay. So this is a picture that you can understand by looking at it. The part one is data collection. So you have already historic data from your application DB, and you'll be also collecting the new data. You're collecting the new data from the API, logs, ETL jobs like Airflow and schedule script. You can put it, store into the S3, blob storage, or GCS, Delta means data lake and BigQuery and all. You can do it by using Spark for Limestream. You can use Beam, Spark processing. With this, you can actually process your data and then store it in the feature store. So this is the batch data side. You can see this snippet, a code snippet, which will mimic the same thing which we have discussed. Let me go to the Google Colab. You can execute in the Google Colab actually. Just create the new one. Yeah, so before you're going to run, just see here, you will be installing minimum libraries that are required for data manipulation, pandas and scikit-learn for the future ML things. And the feast is the for the data storage, but however, it's not needed now. Our date and time for the time series DB to be stored. NumPy for the random data generations things, we can use this all. And then you can write this a function where you are just creating, you're not taking from anywhere. For our practical, we are creating here itself. So this is the definition. I have used this function. You can reuse if you want it actual also. So use this function. What this function is, like what this code block is, you'll be doing stimulating the 1000 records. You can see 1000 records like timestamp, user ID, transaction amount 10 to 500 rupees, and user ID 1299 like this, and then merchant category, whether he is retail, food or travel, something like that. Okay, and there is the things like 0 and 1. So is fraud, 1 means okay, 0 means not. Then you can see here this block is completed, and then you can go with the today's batch. Let's say it is a date that you wanted to be bring the data. So you're just writing this is equal to collect batch data today, collect the batch data today. So this is the function collect batch data, and the date is this one, and today you will be printing the data of whatever the records it is collecting. And then We are running the feature engineering here, you can see. So what is this engineer feature means? Here we are aggregating the data, like from the data that we have received. We are grouping them: user ID, transaction amount, mean max count, is a fraud or not in some. So then we can able to see user ID, average amount, and transaction count how much done, and then we are storing that. So let's see. Just copy this block, come here, just paste here, and run it. So this storing into you're not, I'm doing in Parquet, not in the CSV. You can also do in the CSV as well. It's running right now. Here you can see that. So this is the collected records. A sample means 5 prints. So user ID is 5293. This is the timestamp, and this is the transaction amount, merchant category, and is a fraud or not. Then after engineering, means feature engineering, we collected these features. Okay. So user ID is 1, average amount is 271, and the max amount is 460. Transaction count 16 times here done is a fraud, because by the code, like if it is around between the 300 to 500 between, then and multiple count ratio, then he would be. And other than this, you can see the count transaction count ratio is down and is not a fraud count. So if you click on this, you can able to see a file here with the date. Now these are all the features are saved. This data you can use to train your model. Second thing, if you come little bit down in the same document, you can see these options. Historical data analysis: when you use the batch historical data analysis, periodic model retraining, credit scoring, churn predictions, and forecasting, and real-time data collection. See, in your application, every millisecond there will be a lot of data will be generated, produced. Then you need to do live prediction. You need to have a live streaming, basically. How? From your AWS instances or from your Kafka PubSubs, you can use message brokerings and the streaming the process, and then you can store into the DynamoDB or Redis, and then send it to the model inference. Inference means you are incoming that you are requesting to the model that give an output with some values. So if you see this sample code also here, so Kafka we are doing installing some required libraries, JSON collections and all. So this is something I'm creating here itself, a data, which is I'm creating, generating this data, stimulating that. Event ID, timestamp, user ID, amount, merchant, and the location. Okay, this is quite easy. You can ask any coding agent, means coding LLM, it will be giving you, but check 1 or 2 times properly while you are executing anything. Python is not a big deal. You need to understand little bit of it. It's always it's not that you need to be pro at that. So I can give you one answer. No need of pro at the Python. You need to understand the basic level of Python, like what it is doing, what is this a function, and what is this things, and is it something like string or dict or list, like this. These things are enough. If you understand the code, that is enough actually. So by that you can do your own research and you'll be bringing up anyway that code logic. If you can see here, and we are streaming the process with window, a sliding window actually. So slide window means in a particular time window, I would be taking this data. Okay. So like user ID, event transaction count, and average amount in the 10 minutes. Okay. And then we are processing this. Means inference, a sample kind of inference we would be doing. Average amount is 300 and means the count is 5 and the in 10 minutes is at 400 rupees like this. So this is something if you go through this code probably you will be understanding this. If you copy this block and go here and run this. Now you can understand what's happening here. So here in what it is doing, event 1 user 86 is done some 381. Okay, legitimate score is 0.40 prediction and score is 00. He has done user 11 is done 142 to this user 79 he has done. So this is the event data it collected. User 86 this much, user 11 this much, user 59 this much. This is going to store in your cache. You can store it. So this is a live stream data where you can collect from the different sources like you're from Kafka, Kinesis. Even though I am clicking here, right, in this web portal, my Google also collecting my data actually in the behind the scene. So whenever you also browse something, it will be collecting a data. So this is the events that will be produced from your event things like event driven things of real-time data. In most of the organizations using hybrid approach. So this is the hybrid approach, both together at the production level. So you'll be collecting real-time events live stream and serve to the prediction in milliseconds, and you'll be taking the feedback loop and batch data historical, and you'll train model on a weekly basis. How you're planning, you need to monitor, you need to use some tools, Prometheus, Grafana, Evidently AI for that, means for the drift detection things, and then retrain the model. Use this cache information in your Redis or somewhere for immediate lookup things. Then it would be a more best practice for your model to be get into the productionized way. So this is something I would like to thought you on the collecting data from the different sources. If it is like you are understanding, then please like and share. And if you have any questions, comment out. I'll be trying to answer as soon as I see the message, means comment under the video. I'll be giving you this document under the video description. So please have a look at it. Thank you everyone. Thank you very much. And I'll meet you in next video.